We were tasked to imagine a world where solar exposure isn't the main source of energy. Therefore, we present to you Nereida, where life can prosper beyond sunlight. A short stop-motion film. In the exploration of exoplanets, focused on the possibility of life, we have stumbled upon an original series of species residing in the oceans of Nereida, a planet located in the outermost region of Beta Icari, a G-star, in one of the external arms of the spiral galaxy of Messier 100. These not too complex organisms have been able to subsist thanks to their capacity of survival due to hydrogen sulfide, chemosynthesis, and the inner production of heat inside the planet rather than direct solar energy. The planet's origins date from approximately 3.6 billion years ago. Yet, the initial life forms that inhabit this rocky, water-filled sphere made their first appearances 1.3 billion years ago, as the planet had to undergo a series of events that slowly provided the ideal conditions for primitive organisms. Nereida has a dense atmosphere that includes a mixture of hydrogen sulfide, carbon dioxide, and nitrogen. When reaching land, there is a crust divided in two parts. There is a visible surface containing ice in the form of glaciers and permafrost, as well as igneous rocks full of sulfur, carbon, iron, and other minerals, and also a layer of water with sulfhydric acid underneath. The mixture of water, carbon, and sulfur are what makes bacteria and other simple organisms survive, as they, in order to produce energy in the form of glucose, need a mixture of sulfhydric acid, carbon dioxide, and oxygen. This is the essence of chemosynthesis. These are the building blocks for chemosynthesis. After the crust, there is a mantle of sediments and rocks in constant deformation that surrounds a melting core. Thanks to the friction of the spinning of the planet, the center is kept always warm, and heat exits this region by crossing the mantle and reaching the crust in the form of volcanic eruptions and hydrothermal vents. It's important to note that the closer we get to these two layers, the higher the amounts of minerals, meaning that in the deepest oceanic areas, we can find big populations of thriving organisms. They do not rely at all on solar energy. Rather, the energy for the reactions comes out from the inner heat of the aforementioned system. The oceans of Nereida are filled with vast colonies of bacteria similar to the thiobacillus we know of here on Earth. This bacteria converts hydrogen sulfide into glucose, thus creating a sustainable fuel without the need for sunlight. One of these reactions' byproducts, sulfur, goes through a cycle in which it eventually becomes sulfate. Then, a special type of sulfate-reducing bacteria, also endemic to Nereida's oceans, reduces the sulfate into sulfhydric acid, restarting the cycle all over again. On the other side, there are some heterotrophic single-cell bacteria that prey on other organisms, though their slow metabolism prevents them from pushing other life forms into extinction. In conclusion, photosynthesis isn't the only basis in which life can expand upon and prosper. As far as we have a record of, chemosynthesis is only achievable for microorganisms, uniquely prokaryotes, so no bigger organisms are expected to develop in this planet for as long as its conditions remain intact. Nereida is just not remotely habitable for humans, and will hardly ever be. But this amazing discovery will revolutionize science in unprecedented ways. We must keep up. We must explore, study, investigate, for life of any kind is only the greatest symbol of hope that somewhere out there we will find another rocky, water-filled exoplanet waiting to be discovered and with just the right characteristics to also be colonized. So, look up and wonder, where?